Hi everyone. In this video, we are going to learn how to calculate statistics. I'm going to share my desk. Okay, give me a second. Yeah, this is my desk. So specifically, we are going to learn how to calculate the mean, the median, the mode, the range, and the standard deviation of a given data set. First of all, after we collect the data, and by the way, in the real life, usually that data set means you have millions of millions of numbers, especially if you have a big business or government agency, a huge amount of data. Without certain processing, and those numbers don't mean anything because nobody can extract any information from it. It's just too huge amount of data. So that's why we have statistics. So any number that that are the result of calculation using those raw data, and we call it statistics. Usually it's a sample of data set. So now let's look at our first topic. What is the mean? Mean, another way to say it is average. So average, just another way to say mean. Basically, there are two different kind of means. One is called a simple mean, simple average. The other one is called a weighted mean, and which we don't do that in this video. I will have a separate video to do the weighted mean. Okay, now let's look at this example. Everybody understands simple means simple average. For example, if you have 5 numbers, how do you find out the average of the 5 numbers? When we say average of 5 numbers, we mean simple mean. You just add those 5 numbers together, then divide by 5, right? So now let's look at our first example. And it says the salaries of 8 employees who work for a small company are listed below. So here are the 8 numbers. What is an average salary? So all we need to do is adding this 8 number together and divide by 8. And everybody can do that, by the way. So basically, we just add 40K. Let's use K instead of 0. So just easier to write. 29K and 35.5K and 31K plus 43 and 30 and 27 and 32. So then we divide it by 8. Now, everybody can do this very simple addition and division. Now, I'm going to show you how to do it using Excel if you're interested in that, because Excel is very efficient to do the basic calculation. Now, let me see. Let me add got a new page. So we have 40 and 29. 35.5 and 31 is that 31? Yeah, 31, 43, 30, 27, and 32. Make sure it's 8 numbers. This is number 5. This number 12. Yeah, there's 8 numbers. Now to find out the average, this is what you do. You can do the calculation using any cell, but you need to start with a equal sign to do any calculation. And the mean itself means average. So in Excel, the function is called average. So average, and opening parentheses. Now the Excel waiting for your numbers as input. So I select all those numbers, close the parentheses, enter button, 33.4375. So this is in K. So 33K 437.5. So this is 33,437.5. So that's average. Now, next one we do median. What is the median? Median by definition is, let me write it down. The median is the middle number in an ordered data set. That means you line up the numbers in your data set from the smallest to the largest, or from the largest to the smallest, and doesn't make any difference. And the number sitting in the middle is called the median. Okay, now let's look at our first example. We are going to line them up. Let me take off my glasses. Start with 1. 6 is smallest, looks like. Yeah, 1.61. That's the first one. And one, do we have another 6? No. Now 7, 179, 175. That's the second one. After that, we have 179. And is there 7? No. Then 18, 1.84. Do we have 18 again? No. Then 19. 19. Yeah, just 1.96. This is gone, but no more, just 2 left. So 2.09, 2.11. Make sure there are 7 numbers. This is like gasoline price. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Yeah, 7. So which number is the middle? I already lined them up from smallest to the largest. And this one is in the middle. We have 3 in front of it, 3 after it. So this one is median. So median for this data set, this original data set, is 1.84. So 1.84. Now, before we move on to the next example, let me explain. The median is also beside the simple mean, the median is also the way to measure average. And I don't know if you pay attention to this or not, on TV or in the newspaper, when government says something about household income, they always say it this way: the median household income, right? They don't say the average household income, even though they want to represent average household income, but they say it in terms of median household income. Why is that? First of all, median is also used to measure the average of a data set. But what's the difference between median and average? One to use average and one not to use average to represent the average. Now, let me give you a real life scenario to help you understand why we use median to measure people's average income. Say, suppose you want to estimate the average household income in Kenosha City, okay, in the city of Kenosha. Then the way you do it is that you try to randomly ask some people on the road about their annual income. Suppose they tell you the true numbers. So, for the simplicity, let's say you ask 10 people, they all tell you numbers. So now you have 10 numbers. Say someone tell you I have, say, 35K, another one is 40K, another one 50, another one 80, 70, 65, whatever that is. And finally, that person said, hey, my income, household income is about 1 million. Now it's possible for sure. Now you got your data, 10 numbers. You want to do average to see the average household income in Kenosha. When you add 10 numbers together, do a division, you get the average, right? But we don't actually need to do the division to do actual division to know something is wrong, because that one person, 1 million for that one single income is divided by 10. 1 million divided by 10 is already 100K. You still have 9 other numbers. As a result, your average probably and more likely to be above 130K for the average income in Kenosha. You know something is wrong because it's too far away from truth. So what is wrong? The reason is that 1 million, that number. So we don't have a lot of people in Kenosha whose income is 1 million, certainly not in any place, in any country. In other words, one single number, extreme number, which is not representative, and we are calculating average of all people, certainly that one person cannot represent the rest of us. But at the same time, it has huge impact when we do simple average on the final result. That's how the final result is distorted. The impact from that one outlier number is too huge. But when you consider how we do the calculation of median, we line up all of the numbers from smallest to the largest. Smallest at the very beginning, largest at the very end. We pick the very middle number as median. In other words, we get rid of extreme numbers. No matter how extremely small, how extremely large, they all have an impact on your final simple average calculation. If you distort it, your final result. Median, the number in the middle, almost always tell you the truth. The reason, if you think of in real life from common sense, if you ask many people, if the truth is that most people have an income similar to each other, maybe in Kenosha anywhere from say 30K to say 70K, most people will be within this range. That means they are in the middle. We have a small number of people who have lower income. We have a smaller number of people who have a higher income, but majority of people will be in the middle chunk. That means median represents most people. That's why median can measure the average better than average itself, if in the case you have extreme values exist in your data set. Okay. Later on, we come back to another example why we can use median to measure the average. And when we have data set, I'm going to show you. But for now, let's move on to the next example. And the salaries of 8 employees who work for a small company are listed below. So basically the same number, same data set when we calculate the simple average. But this time we calculate the median. So now we are going to line them up again. Let's see. Start with 2. 2 is lowest, looks like. 27 is lowest. 27. And then this is got another 20, 29. This got more 20. No, let's start with 3. 3, 1, 3, 0. So 3, 0. This is gone. 3 again, 3, 5, 3, 1, 3, 2, 3, 1. So 31,000. This one is gone. 3, 5, 3, 2. Yeah, 3, 2. This one is gone. We line them up from smallest to largest. Another one, 3, 5, 5. And this is gone. Then we have 2 more 4s, 40,000 and 43,000. Yeah, that's it. We cover all of the numbers. 1, 2, 3, 4, 5, 6, 7, 8. That's right. Now we need to find the number in the middle. Now notice that this time we have 8 numbers. Last time we have 7 numbers. For our number of numbers in the data set, the median is just a single number sitting in the middle. You have equal number of numbers on either side. But for even number of data set, you're not going to have a single number in the middle. So we are going to have 2 numbers in the middle. 2. So you have 3 in front of them, you have 3 out of them. That's why we call this in the middle. Whenever you have 2 numbers in the middle, you do a simple average between these 2. So that means the median is just one single number, equals 31,000 plus 32,000 divided by 2. So that's 31,500. And that's the median. Yeah, that's how we calculate the median of the data set. Now, next topic, what is a mode? Mode is not a way to measure the average. We don't go into the detail of that as long as you know how to, what the mode is and how to calculate the mode. By definition, the mode represents how often a number occurs in the data set. In other words, the number that occur most frequently in the data set. So the target is a value who occurs most frequently. Now we look at 2 examples here to demonstrate this. The following is a number of problems that Ms. Matty assigned for homework on 10 different days. What is the mode? So apparently on day 1, she assigned the 8 problems, day 2, 11 problems, and so on. Since we are looking for mode, this is the values. Mode represents the value with highest frequency. So let's look at the frequency of each number. It doesn't matter which order you do that. So 8, let me see how often 8 show up. Only once. Only once. And 11, how many times 11 show up? Only once. And 9, how many times show up? 1, 2, 3. 9 occurs 3 times. And 15 only occurs once. And 18 occurs once. And 10 also occurs once. Now I go over all of the data. Now, which one has highest frequency? This one's frequency, highest frequency is number 9. So 9 is called the mode. It's not this one, this is frequency. The number with highest frequency is called the mode. So the mode is 9 in this data set. So when you talk to other people, say the mode of the data set is 9. And that just tells the other person that 9 is the most popular number in this data set. It occurred most frequently. Okay, example 2. In the crash test, 11 cars were tested to determine what impact speed was required to obtain minimum bumper damage. Find the mode of the speeds given in miles per hour below. So all these numbers represent miles per hour speeds. So just like in the previous one, we just need to figure out how often each number occurs. So for number 24, once, twice, 3 times. Number 15, once, just once. Number 18, just do it one by one. 1, 2, 3, 3 times. Number 20, once, just once. Next one, number 22, once, also once. Next one, number 26, once, twice. No, that's all, no more. And when we look at these frequencies, they have 2 numbers that are equal frequency and they're highest. So this time they're equally important, equally popular. You have 2 modes, one is 24, one is 20. So it's a modes, 24 and, oh, I mean 18. So the 18 is 3 times, 24 and 18. You don't do any calculation between these 2 because mode represents a specific number in the data set that occurs most frequently. So that number has to exist. So this is 18 and 24. Now next one, what is the range? Range is a way to measure how dispersed a data set is. If a range is very narrow, that means that data set is very much concentrated. If a range is very large, so your numbers within that range are all over places, that's very dispersed data set. So it's a way to measure the dispersion of a data set. But in terms of how do we calculate it? Actually, it's very simple. You just use the highest value in the data set, subtract the lowest one. So basically range equals maximum value in that data set minus the minimum value in that data set. So very simple calculation. So here's some number. Let me write this clearly. This out of printer, I don't know why printer print this negative sign this way. So we have this data size. This is Miss Kaiser lists these 9 numbers on the blackboard. She asks students to calculate the range of this data set. So now range is maximum minus the minimum. So we look at which one is highest, that's 14. When you have negative number, you only look at the highest, you only look at the positive number for the highest, because positive is always bigger than negative. 14, 7, 14 is high, this one is higher, 19 is even higher. So 19 is the maximum, minus the minimum, only look at negative numbers, because any negative number is smaller than positive number. Negative 12, this is lowest so far, still lowest, still lowest, still lowest. So negative 12 is the lowest. Minus negative, minus minus is plus, so 19 plus 12, that's 31. So that's the range. That means from lowest number to highest number, the distance between is 31 units. So that's the range. Next one. Now, next one is the last topic for this video, and this is a little bit longer topic, and also super important. It's very useful in the real life. What is the standard deviation? First of all, we use a standard deviation just like the range to measure the dispersion of a data set. And there's some drawbacks using the range. You see that already. It's very simple to calculate the range of data set. Just a simple subtraction. Just like anything else in the real life, there's a trade-off. It's easier to do calculation, but it's not a reliable measurement in terms of measuring dispersion. Without going into depth into that, why it's not accurate, we just focus on this standard deviation calculation. In terms of calculation, it's way more complex than the range. Again, as a trade-off, it's a very reliable measurement of dispersion of any given data set. So let's look at how this works. I'll try my best to make this make sense to you in terms of why this measurement can tell the truth about the dispersion of a given data set. Okay, we have 2 students now. These 2 students are called student A and student B. They both take 5 tests. And these 5 tests are the same test for both students. They just have different scores. So student A gets these scores, student B and these scores. Now, first, we want to calculate the average of these 2 students. And average is part of calculation of standard deviation. That's why we need to do average first. So let's do that. This is a small number. It's easy to do average. Average of student A, 78 plus 79 plus 80 plus 81 plus 82. And divide by 5. And if we do this calculation, it's very simple calculation, you will get 80. That's average, simple average. Now let's pause right here just for a moment. Remember just a moment ago I said we can use the median of the data set to measure the average, right? Now this average is 80. What is the median? If you look at these 5 numbers, they already line up from the smallest to the largest. So which one is the middle? 80. The median is exactly equal to the average. Is that a coincidence, or is it something that has to be? Now it goes like this in mathematics, big number theory. Again, we're not going to get into that, but let me tell you, whenever you have enough numbers, and the very reason this median exactly equal to the average is because this data set is symmetric. Say this is in the middle, 1 to the left is 1 less than 80. 1 to the right is 1 more than 80. 2 to the left is 2 less than 80, and 2 to the left is 2 higher than 80. Symmetric. Whenever you have a symmetric data set, the median and the average pretty much going to be overlapped. They are the same thing, or very much the same thing, very close to each other. But how do you know if a data set is symmetric or not? That's a critical question, right? Now, here's a beautiful part. For most events in real life, as long as you have enough numbers, and then the distribution of those numbers will be a bell curve. And I guess most of you heard of that. That means what? Symmetric. It's symmetric. That means you can use the middle number represent average. If you have millions of numbers, just pick a number in the middle, put it much close to the true average without adding million numbers together divided by 1 million. That's how powerful it is. Okay, now let's move on. Come back to our topic here. Average of second students, 60, 70, 80, 90, 100, divided by 5, guess what? You got 82. Again, this is symmetric. You can try this, you got 82. Now, both students have the same average. Now, this is something really interesting. If we ask this question, what's the performance of these two students? If that question only means numbers, average, no difference. They all have same 80 as average, is that right? But if we ask the question from a different angle, say, which student's performance is more reliable? Think about that question. They have the same average. Overall, not much difference if you only look at the surface without looking what's inside that data set. There's no difference. But if we ask, how about the performance? Which student performance is more reliable? Everybody will say student A, because all of those 5 numbers is very close to each other. That means it's very stable, very stable. And if we get another test for these 2 students, and probably you would say the number, the student A will get somewhere close to 80, because that's been the history of that student's performance. It's very reliable predictor. But as of student B, if I ask what is student B going to get for the next test, who knows? Oh, how come it's 10? It should be 100, by the way. 70. Sorry about that. That's typo. This is I don't know how that happened. So if we ask what's the student B going to get on the next test, it's very hard to predict, because from the student B's history, his or her number are all over the place, right? Can be anywhere. Maybe next time he got 60, maybe 100. Just nobody can tell. The range is too big. The data set is too dispersed. In other words, without looking at the data set, we don't know student A's numbers are very much concentrated, very stable, very reliable. Student B's numbers are very dispersed. We don't know that information if we only look at average. In other words, in order to tell which student's performance is more reliable without looking at the data set itself, we need another measurement. And this measurement will tell us how dispersed the data set is. And that measurement is called standard deviation. Now let's do some calculation of standard deviation for both data sets and then compare the results. After that, we have a very good idea how good this measurement is. Okay, now the formula to do the standard deviation calculation looks messy, and you don't need to do this by hand using using the calculator even. You just need to understand this formula. I'm going to show you how to break it down into steps. If you want to do it using calculator by hand, you can follow these steps. Instead, you can also use Excel to do it in just one step. I'm going to show you both. So to do it manually, let's use a student A as an example. Numbers are 78, 79, 80, 81, 82. We already know the average is 80, right? Because average is part of the standard deviation calculation here. Now average is 80, we already know that. Now the step 1. Step 2, you you use each individual data in the data set to subtract this average. What is X? X represents the data set, represent all of these numbers. It just represents all of these numbers one by one. That means X equals 78, X equals 79, X equals 80, and so on. So let's do the subtraction. 78 minus 80, so we minus the average, equals negative 2. 79 minus 80, that's negative 1. 80 minus 80, that is 0. 81 minus 80, that's 1. 82 minus 80, that is 2. This subtraction is called deviation. It just tells you how far this individual score from the average. 78 minus 80, negative 2, this deviation just tells us this number is 2 points below the average, 2 points away from average, standard deviation. This is not standard deviation, it's deviation. Now we need to square this. We need to square that. Third step, square that. X minus x, x bar means average squared. That means we need to square these numbers one by one. So we get 4, negative 2 times negative 2 is positive 4. 1, 0, 1, 4. Square each of this one by one. We finish the third step. Then we do this step sigma. So maybe I move on to the next page. Let's see. Yeah, I have a lot of room on the next page. So next step. Step 4, doing sigma. Sigma means summation. Add them all together. Add what together at the last step after you do all the squares. So we are going to add these numbers together. 4 plus 1 plus 0 plus 1 plus 4, this equals 10. Now another step is divided by n minus 1. So number 5, step 5. Step 5, we divide this result by n minus 1. So we do this part. What is n minus 1? First of all, n represents how many numbers you have in your data set. We have 1, 2, 3, 4, 5. We have 5 numbers. So n equals to 5. But why minus 1 then? Minus 1 goes like this, and to make things simple. And n, whenever you have a sample of data to do all of this statistics calculation, you divide by n minus 1. If you use the data set for the whole population, then you use n instead of n minus 1. And in this course, you only deal with sample data set. You don't deal with population. That means you always divide by n minus 1. So in our case, this whole thing here, summation equal to 10, 5, and 5. So 10 over 5 minus 1. We have 5 numbers, n equal to 5. 10 divided by 4 is 2.5. Now, final step, standard deviation equals square root of this whole thing. Square root of this whole thing. So this is a square root of 2.5. Let's see what we get. We just take one decimal digit. 2.5. Square root is half power, and you do it using your calculator, and we get 1.58. Let's do two digit, 1.58. And this is a standard deviation of the student ACE scores, and it represents the dispersion level, how dispersed the data set is. And by having the single number, I'm sure it doesn't make much sense to you because it's just number 1.58. So what? What does it mean, 1.58, right? Yeah, very much so. I would think so too if I learned this as a student. Now, I'm going to calculate the same number measurement, standard deviation for student B, and then we compare. But before that, in order to speed up this process, I'm going to show you how to calculate the standard deviation using Excel so that we can make things really fast. And you want to do it using Excel too, because it just save a lot of time. So now I'm going to show you how to do that. Look at the left-hand side of the screen. See, we have all of these numbers, student A and student B. I'm going to delete that and redo it. So this is student A. This is for student B. Now to calculate the standard deviation, STD. Okay, you start with equal sign again. Now you need a different function now. Standard deviation, just type STD. Now you see the first one highlighted with the dot P. P represents population, which we don't do. And we use a sample, this dot S. We use the second one. Double click that, make sure it's S. Then the Excel is waiting for your data. So select this 5 scores for student A and close parentheses. I should get 1.58 something. 1.58, 1.39, exactly the same thing actually. So we just verify our number is correct. Now for student B, it's much easier because we just do another standard deviation button. I mean the function. We have 60, 70, 80, 90, 100. That's our data set. Now standard deviation from the Excel. I already copied these numbers here. So I do another one equals STD and sample. Now highlight the data set and close it. 15.81. Now, without looking at the data set, suppose we don't know those two students' scores, just by looking at this two. This second one is almost 10 times as big as the first one, almost exactly 10 times. Since it's a metric dispersion, this number is way more dispersed. This data set is way more dispersed than this data set, and you know that's true. Look at these numbers, all big range. The student A, very narrow range from 78 to 82, only 4 points. This is 40 points. So standard deviation is a very good measurement of dispersion of given data set. It tells you what's going on inside without knowing that those data sets. Okay, now I have a specific example from the homework. Now using this, we go through all of the calculations that we mentioned before. So we calculate the mean of this data set. Mean means average, add them together, divided by 12. This represents the fuel efficiency of 12 trucks. That means 21 miles per hour, 26 miles per hour, and so on. Now, again, everybody know how to do the average, right? 21 plus 26 plus 23 plus 26 plus 15 plus 24 plus 23 plus 32 plus 23 plus 21 plus 25 plus 22. I divided by 12, right? That will give us the average. Now, here's the problem. This is only 12. For a big company, they have way more than 1,200 trucks. Think about Amazon, right? So are you going to add thousands of numbers together and divide it to get average by hand? Or even using calculator, push so many times button? That's why Excel is excellent tool to do that. I'm sure everybody can add 12 numbers together divided by 12, right? But again, let's use Excel. I do that just in case you want to learn how to do things using Excel. That will help you a lot down the road whenever you need to do some calculations. So let's say I already copied this in here to prepare record this video. Make sure this is the right one. Yeah, it is the right one. So now these are 12 numbers. From number 3 to number 14, 14 minus 3, 11 plus 1, 12. Yeah, 12 numbers. Now we need the average. Equal function is called average. And then double click. Make sure the opening parentheses show up. Then now I select data, close parentheses. 23.4. Let's take just a 1 decimal digit. 23.4 miles per hour. That's average fuel efficiency mileage. So we get this done. Now median. We have these numbers. We are going to line them up. Let's say smallest is single digit, 15. That's gone. Normal 1. Let's look at 2. Do we have 20? We don't have 20. So 21. 21. This is 21. Normal 21. Let's look at 22. 22 is gone. Normal 22. Now 23. 23. I got 1 already. Another 23. And another 23. Just be careful. And then 24. We got 24. It's gone. Do I have more 24? No, just 1. Then do I have 25? Yeah, 25. 125. Just 1. Then 26. How many 26? 126. Oh, 226. 26. And then just 1 left, 32. Is that right? Yeah, just 32. 32. And double count to make sure we have 12 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Now, even number has 2 numbers in the middle, right? So either side has 5. In the middle, I have 2 more. 1, 2, 3, 4, 5. These 2 are in the middle. There's 5 number on the other side. So the median equals 23 plus 23 over 2. You still get 23. And mode. So if you look at which number occur more often after you line up, it's very easy to see that. 21 occurred twice, 23 occurs 3 times, and 26 occurred twice, others occur once. So 3 is highest frequency, so the mode is 23. Yeah. The range is also easy to do. We use the highest number, which is 32 at the end of this lineup, minus the lowest number in the front, 15. So range is 17. So range is 17. Now standard deviation, we're just using Excel. Standard deviation. Let's say, let's get rid of this so that it don't STD equals. You don't have to type this STD. It's just a labeling for you to see it because I'm recording this video. And STD, and make sure select sample. Select this data set. 3.98. I don't know how many decimal digits because I didn't pay attention to the requirement. Let's just take 2 decimal digits. That would be 3.99. You do this according to your homework requirements. Yeah, that's the end of the video. Demonstrate how to calculate statistics. See you guys in the next video.